Okay, we're alive again. We're alive again. So we're on page 38, and we're looking at covalent bonds. We just got a few more minutes to go. And as you look on page 38, figure 2.5, formation of a covalent bond. And so they stabilize each other. They share that outermost electron that they have in their valence. Now, as you look to the right, come down a little bit, you see it says two atoms in the 1, 2, third paragraph. Two atoms can share one or more pairs of electrons. So when they share one pair of electrons, that's a single covalent bond. If they share two pairs, that is a double covalent bond. If they share three pairs of electrons, that's a triple covalent bond. So come down to table 2.1 and look at the illustrations. As you look at the first one, you see the carbon. It had 4 atoms in its outermost shell, and now a hydrogen, which has only one shell and one electron, joins it. You have 4 hydrogens joining that carbon. So they're sharing their electrons. They're sharing one pair of electrons. You come down to the middle one, and they share 2 pairs. That's a double covalent bond. That's the kind of bond we want to have in the fat we eat. The oils that we get from olive oil, from walnuts, from peanuts, from salmon. Good stuff. That's where we get those good omegas, omega-3 oils that have those double bonds. They're good for us. Don't want to eat too many saturated fats. Want to eat the monounsaturated and polyunsaturated fats. Those are the better ones for you. And then they can even share 3 pairs of electrons, as you would see with nitrogen. Okay? So much for those covalent bonds, single, double, and triple. Now, look over on page 39 and look at the middle of the first column, and you see carbon dioxide, Carbon is in the middle. That's the one that's gray, got 6 protons. Here are 2 oxygens, one on either side, and they share, the carbon shares 2 electrons with poles of a magnet, positive on one side, negative on another. Look at the top of the second column, and you see the 2 hydrogen molecules up at the top, nonpolar covalent. They share that one pair of electrons right between them there. Then you come down to where you have oxygen and 2 hydrogen. Instead of being like this, to the oxygen in the middle, came like that. So when they did that, polarity, or a little bit of positive on a little bit of negative on the other. That's why when you look at the one to the left, you see the positions, how they're sharing the electrons. Then you look to the right, and you see down there by the blue hydrogens, you see this little Greek letter and positive. And then at the other end, you see Greek letter and negative. So polar covalent bonds have a little bit of charge. Not a lot, but a little bit. Enough to be detected. Positive on one side, negative on the other. So those are called polar covalent bonds. Come down to the next to the last paragraph. Under polar covalent bonds and hydrogen bonds. We're going to finish on hydrogen bonds. And you see it says molecules with such partially positive and negative ends have what is known as the dipole. I'm not going to ask you about that. Or a polar covalent bond. That's what we will hear over and over again. Come on down below to the 2 sentences below. It's already stated what I just said. In the case of a polar bond, we have a partially positive pole and a partially negative pole. We have molecules that contain primarily polar bonds are known as polar molecules. We will run into that over and over again. Now look at the very last paragraph. When polar molecules are mixed together, their partially positive and partially negative ends attract one another. The positive end from one of the molecules is attracted by the negative end of the other molecule. The polar water molecules align so that the partially positive hydrogen atoms line up next to the partially negative oxygen atoms. Just what I said. Positive over here, negative over here. They draw to each other, which results in weak attractions called hydrogen bonds. Page 40. Now, as you look at the top illustration, you see the red oxygens and the two little blue hydrogens. You see the negative up there by the oxygen, the positive by the hydrogens. And look what the negative is doing. It's drawn to one of the positive hydrogens on another molecule. And you see all these little dotted lines? Those are hydrogen bonds. This is what allows the water to have some elasticity. It's like a net. Have you guys ever seen a water strider? They stride on top of the water because the water has enough hydrogen bonds, so when their weight is on it, it just bends a little bit. It doesn't break. You can even do it with a penny. You can take a penny, take a cup of water, and maybe use your tweezers or whatever, but slowly and carefully try to put the penny right on top of the water. Not going in like that, as flat as you can get it. And that penny will float because those bonds help hold the water molecules together. So there is a certain small density to water. That's why it crowns up. A drop crowns up. Okay. You can do the quick check on page 41, and when we come back on Thursday at 1 o'clock, module 2.3. We'll see if we can finish this in a couple hours. All right. You guys have a nice afternoon. I look forward to seeing you. Bye-bye.